let's look at using trig values to write our vector in component form. So it says consider some position vector v with a direction angle theta. So let's draw that out to see why these equations make sense. So let's assume it's in the first quadrant, but it could be in any of them. And if it has a position vector v that is x, y, then it necessarily starts at the origin, or we could draw it such that it starts at the origin and ends at the point x, y. Now, if that's the case, then I could draw a right triangle with one side x, one side y. And then what would the length of the hypotenuse be? Well, it's the same length as the magnitude of the vector. We already have a name for that, and we'll call that the magnitude with that symbol there. Now, what these two equations here are saying, cosine theta equals x over the magnitude and sine theta equals y over the magnitude, well, these just come from our SOHCAHTOA, right? So let's draw in our angle first, theta, which is just that angle in standard position where the vector lies on the terminal side of that angle. And so cosine of theta would be adjacent over hypotenuse, and the sine of theta would be opposite over hypotenuse. So that's what these two equations are saying. And then each equation, we're solving for either the horizontal component or the vertical component there. So from there, it says you can write this vector v that started out as this position vector just as a nice in component form. But then you can rewrite that x as the magnitude times cosine theta, and then the vertical component as the magnitude times the sine of theta, where the magnitude is just what we would expect it to be with the Pythagorean theorem. So now this exercise says write that vector v in component form if we know the magnitude and the angle. Here they're calling it alpha, we could call it whatever. Okay, so what are they telling us? They're telling us that the magnitude is 8. Okay, so the magnitude of this vector v is 8. Well, then I know that a, okay, and again, that's just using, in this case it's a, here up here we're calling it x, is the magnitude times the cosine of that directional angle. In this case, it's 45 degrees. And then I'll just kind of put this over here. B, because I'm on a roll, B is going to be 8 times the sine of 45 degrees. So this gives me 8 times root 2 over 2. Over here it's 8 times root 2 over 2. So this is 4 root 2, and then over here is 4 root 2. So how could I write this, how could I write it in component form? Well, this vector v would just be 4 root 2 I plus 4 root 2